All right, so we're looking at lesson 9-0 today, area of shapes. And today's learning intention is to classify shapes and solve for their areas. So let's go ahead and take a minute and get that down. So all the shapes we've talked about a couple chapters ago, we're now going to be solving for their areas. And today we're also going to be looking at their perimeters a little bit. But as far as our lesson goes, we're just writing down areas and formulas. Okay, so the rectangle definition is 4 right angles. Okay, and this should be a bit of a review. If we remember going back, we learned that rectangles have 4 right angles. And the area of a rectangle is, a lot of us in the past have learned length times width, which is also the same as base times height. So we can call it base times height, or BH. So B is my base down here, H is my height here. Okay. The definition of a parallelogram, if we remember, it is 2 pairs of parallel sides. And the area of a parallelogram is also base times height. And now we're going to talk about altitude just for a second. And altitude is just a fancy name for height. So when we talk about an airplane's altitude, we're asking how high is it in the sky. So altitude is just a fancy name for height. And the height is going to be perpendicular to the base. Okay, so I have the height of my parallelogram here, and you can see perpendicular, which is what creates that 90-degree angle. Okay, and then I have definition of a triangle, which, what do you think this is? What do you think? Going back, what is a triangle? It is a 3-sided polygon. Okay, we just need to have 3 sides. And the area, we have talked about this in the past, I believe a lot of times you hear it as 1/2 BH, which is the same as BH divided by 2. So when you're taking 1/2 of it, you're just really dividing it by 2. So if you look at our triangle down here, we have our base B times our height, and then we divide that by 2. And the height, once again, this height right here, must be perpendicular to the base. So the height must be perpendicular to the base. Okay, and now we're going to talk about a trapezoid. We have a picture of a trapezoid right here. And if you remember, a trapezoid has 1 pair of parallel sides Okay. Okay, so now let's talk about the area of a trapezoid. This is going to be the height. We're going to have times base 1 plus base 2 divided by 2. So another way you could say it is base 1 plus base 2 divided by 2 and times it by the height. Okay, and so if we look down here at our trapezoid, we have base 1, then we'd add it to base 2. Okay, we would divide that by 2, and then we would take it times our height right here. Okay, moving on. Rhombus definition is 4 congruent sides. this over. And there's two different kinds of rhombuses, really. We have a rhombus that's kind of like a parallelogram. So I'm going to write this off to the side. And if we're finding the area of a parallelogram type of rhombus, if you think about it, we have parallel sides like this, not on all rhombuses. Remember, the definition is 4 congruent sides, but a rhombus takes the properties of a parallelogram. Okay? And so this is A equals base times height. And then we have rhombuses that are also like kites. And that kind of area is going to be A equals, and this is diagonal 1 times diagonal 2, all divided by 2. And I'm going to come back to this here in a little bit after I talk about the kite. I'll come back. And then we're going to talk about diagonals real quick. Diagonal 1 and diagonal 2 are the entire diagonals. Okay, so entire, just going to emphasize that. And I'm going to talk about that also here in a second. And we're going to go into the kite definition. The definition of a kite is 2 pairs of adjacent congruent sides. Okay, so what we're talking about is 2 pairs of adjacent congruent sides. So if you remember back to the kite, we have a congruent side here and a congruent side here. And they are touching. Okay, and then we have this side that is congruent and this side that is congruent. They are touching, making them adjacent. So I have a pair of congruent sides here that are adjacent, a pair that are congruent here that are adjacent. So now I'm going to back step to the rhombus, and remember where we wrote kite out to the side here. Well, if you think about it, we also have these are congruent and they are touching. And even though these are congruent with these, they're still congruent with each other and also touching. Okay? All right, so now I'm going to go ahead and write the definition, or not the definition, the area of a kite, which is going to match this. So it is D1 times D2, which is for diagonal, all divided by 2. Okay, and we're going to talk about diagonals real quick. When we say diagonal 1 and diagonal 2 are the entire diagonals, what it means is it's not just this and this, it's this whole thing and this whole thing. Okay? So it's this whole diagonal and this whole diagonal. So when we do our stations here in a little bit, if you see something like a kite or something like this, that gives you a unit, like a 3 here, we know that this side is also going to be 3, and we need to know the whole diagonal. So the whole diagonal would actually be what? 6, right? Okay, very good. We're going to come down here. What kind of angles are created at the intersection? So it's talking about the intersection of the diagonal. What kind of angle is created right here? Do we remember what? Right angles. Very good. Yes. And it is a right angle all the way around if we remember from a couple chapters ago. And that is the same thing here. We have all right angles. So this is 90-degree angles or right angles, either way. Okay.